We're going to finish up section 3 by talking a little bit more about similar triangles. When we look at this first example, are the two triangles similar? Yes or no? So first off, it's probably going to be yes, but we have to be able to justify why. Because these two lines are parallel, angle K is congruent to angle N, and we could say angle J is congruent to angle M by the same reason that they're alternate interior angles. We could have also used vertical angles. So they are similar, and that's by angle similarity. And to find the value of x, we want to set up a proportion. 16 and 4 go together. And then go back to the original triangle over x minus 3. So I'm going to cross multiply. And remember, you've got to be careful while you're cross multiplying that you distribute properly. So I'm going to take 16, I'm going to distribute it. So I got 16x minus 48. And then I'm going to take the 4 and I'm going to distribute that as well. We get 4x plus 72. Okay, so when I start solving, I subtract the 4x, I get 12x equals, and when I add 48 to both sides, I get 120. So x is 10. So even though it doesn't ask, if I had to plug it back in, this side here is 28, and this side here is 7. So are these two triangles similar? And we want to justify. So I know that both of them have a right angle, and I know that both of them have angle M. So these are actually similar by angle similarity. And what I want to do is I want to redraw, let me draw a right triangle. I want to redraw triangle PQM in the same shape and same direction as angle L, or triangle LMN. Okay, so now let's move this down. It's not on top of the words. I'm taking this triangle here, PQM, and I'm flipping it. M is still over here, so they match. My right angle is now where my right angle is, and P is down here. So PQ is 10, QM is 12. My ultimate goal is to find LM, this side up here. Okay, so I have 15 in x, and I have 10 and 12. So 15 over 10 equals x over 12. When I cross multiply 15 times 12, that's 180. So 10x equals 180. So x is 18. And that's also LM. Now, are these two triangles similar? Same reason as before, angle similarity. We have corresponding angles, we have a reflexive angle, and we have more corresponding angles. So, I want to find x and I want to find ED. So I want to find this entire side here, and I don't have enough information yet because that has an x. So 6 corresponds with the 12. And then in the small triangle, it's x plus 5. And in the big triangle, it's not 9. Most often, the mistake made here is we choose 9. The entire side is those added together. X plus 5 plus 9. Or this can be 14. So I'm going to change that to 14. I'll change it in the next spot. So 6 over 12 equals x plus 5 over x plus 14. When we cross multiply, 12 times x, 12 times 5, 6 times x, and 6 times 14. So we subtract 6x, we subtract 60, that's 24, so x is 4. Now I want to plug that back in. If I plug in a 4 here, I get that this segment here is 9, and 9 plus 9 tells me that ED is 18. We got one more example, word problem here. So Ms. Jenkins notices that a 20-meter flagpole causes a 25-meter shadow. So let's go ahead and draw that. We have a 20-meter flagpole with a 25-meter shadow. Nearby a telephone pole, that we don't know how tall, has a shadow of 35 meters. How tall was the telephone pole? We're going to set up a proportion, just like we have before, just like we have in the triangles, as well as not in the triangles. You can do 20 over 25 and x over 35, or you could go a cross shape with height over height and shadow over shadow. Either way, you should still get the same answer. I'm going to do 20 over x equals 25 over 35. When I get that, I got 25x when I cross multiply equals 700. Then when I divide that by 25, I get that x is 28. And let's put some units because we're talking about the height of the telephone pole.